Hi everyone, welcome to our first Halloween special. In this video we'll be making a motion controlled spooky light and power it with batteries, grow a pumpkin and carve it and pop everything in there and hopefully come up with a spooky jack-o'-lantern. To do that we need a motion sensor module. This is HCSR501 module. It's about $1. You can even find it cheaper from AliExpress. It has 3 pins on it. It's the supply pin, VCC output, just gives you a digital high output when there's motion, and the ground pin. This module is powered by 5 volts, but if you notice there's a regulator here, and it's actually the chip that it has here needs 3.3 volts, and you'll be powering this with 3 batteries. We don't want to go up into 5 volts range, so we will just be using these little pads here to bypass the regulator on the module, and we will just provide 3.3 volts from here instead, and these other pins will be same, ground out, it's all good. We'll just be using it. On the side of it, it has 2 ports. I recommend you to just get these ports to minimum first, because we just want to try everything in their absolute minimum position. That you see over here, the first one controls the sensitivity. The second one is for the time. So when it senses motion, based on this, the value of this pot, it could change from a couple of seconds to trim it a little bit. It goes to minutes, and I don't know the maximum value to be honest, but it's from seconds to minutes. So yeah, just put them all the way down to begin with, so we can see and test a few things and then adjust them as we need it. Good old PIC10F over here. We'll just be using the spray card port for this project. You don't even need that. You can just hook up your LED straight into this one, but we're just going to use this for the brightness control just to get things a little bit more spookier. And what we have here is a 3.3 volt low dropout regulator. It's and some input and output caps, and our PIC10F, and just breakout pins. They're all VDD, VSS, the ground, GP0, 1, 2, 3. And here I just put a current limiting resistor here. It's 15 ohms, and this will be the LED output. So we'll be low side switching the LED, like so our LED's anode is connected straight into the 3.3 volts, and the cathode is driven by GP pin GP2. When we clear GP2, when we set it low, the LED will be on. If it's high, then the LED will not be on. The reason that I did this is because I want to get a decent amount of current through the LED, which is going to be around 10 milliamps in this case, because the LED that I will be using is a high brightness LED. It can take 30 milliamps. And with these LEDs, their forward voltage drop increases exponentially with the current that's passing through them. So 15 ohms is a good enough current limiting resistor, but I don't want to lose any voltage because if I was driving from high side these LEDs, then there's some voltage drop out on the pins. It's like 0.2 volts less than the supply voltage, so it would be like 3 volts. I want to get the entire 3.3 volts onto the LED. We also have a battery holder. Again, this is something that you can get for very cheap, like cents, really, 20 cents, 30 cents. You can get like a bunch of them even for cheaper. I have some jumper wires here that we're going to use. We're not going to solder everything. We'll just solder a few things, but it's going to be a true prototyping fashion thing. And yeah, high brightness green LED in this case. 3 AAA batteries to pop in there and power our project, and some heat shrink that you're going to use, maybe in these wires, because we don't want shorts in there, especially with batteries. You don't want to go that path. Let's have a look at our circuit. It's quite simple, really. We'll be providing 3.66 volts with the batteries. These are rechargeable batteries, the nickel metal hydride batteries that I'll be using. Is 1.2 volts of nominal voltage. 3 of them makes 3.6 volts. But when they are fully charged, they can go up to 1.5 volts. So it's and AAA batteries, could be even a little bit higher than 1.5 volts. So And we have this low dropout voltage regulator here. I use this LE33CZ. You can use anything you want really. Any low dropout regulator will do here. Just 2.3 volts. That's all good. 1 microfarad input cap and 10 microfarad output cap. You might want to look into whatever regulator that you are using. You just want to look at this data sheet to get the best values for input and output caps. In my case, this was like 2.2 microfarads, but any value bigger than that will also do, not a problem. And then our voltage regulator is connected to our PIC. We will not be using GP0 and GP1. I'm just going to reserve them for further projects where we can use some of the analog features of the processor. These are both analog pins. Instead, we will just use GP3 and GP2. These are digital only pins. And we will use GP3 to get the motion detection signal from our motion sensor, HCSR501. And GP2, we will be using it to drive the LED and its low side switching. So our LED is connected straight to the regulator's output. It will be driven by 3.3 volts whenever GP2 is low. And so we will be syncing current to GP2 pin. So one of the trickiest parts of this project is to get this motion sensor module working with 3.3 volts. So if you look at the bottom, there is like on the top right corner, there's these 3 pads, and we need to solder a wire into the one which says H, and the one above that is also connected. You can test it with your multimeter, and then we will supply 3.3 volts from here, bypassing the regulator, and that would give us the optimal power consumption by the module. And since we only have 3 batteries and we don't want to pop in more batteries in there for no reason, and everything else can be powered, our micro, our LED, everything else can be powered by 3.3 volts, there's really no need to use this regulator here on the module. So let's pop this on our soldering stand. Get in there and see what we can do. You just need some wire for that, some hookup wire. I have 24 AWG solid core wire here. So I'm just gonna strip a good amount of wire. And now before getting in there, I want to provide a big surface on the wire. So just with your side cutters, create an angle cut. It's as small as it can get really, because we just need a really nice big surface area to get onto the pad. And like while you're cutting it, just hold the part that you're cutting so it doesn't fling. Now this looks actually really sharp and real nice. There's a good surface area there. We're just going to solder this large surface onto the pad, but this will be a lot of stress for our solder joint because it's going to be like the carrying entire wire, and once we wiggle things around, the solder joint will have too much stress. So I'm just going to use this mounting hole to support our solder joint a little bit more. I'm gonna go through the mounting hole a little bit and then just mount the wire just a little bit around the PCB, just to get everything nice and tight, so still there will be a significant amount of stress on the solder joint, but not as much. So I'm just bending the wire to meet the pin, the pad that we're going to solder it, and then I'll just push it a little bit downwards as well, just to put it there nicely. Okay, now the rest of it I just can't do it by hand, everything wiggles too much. I'm just going to use the soldering stand. Okay, now this is in place, and yeah, looks like we are there. We have a lot of surface in there too. Is to apply a bit of flux because you want to clean the module surface as well as your wire. So just before soldering, check your wire again. It has to be touching the bottom pad that has an H right next to it, and it shouldn't be touching the one at the top. It could touch the pad above it, that's fine, they are connected, but we should be soldering somewhere here. And I want this joint to be absolutely perfect because we will be wiggling this thing in our application a little bit, and yeah, we don't want to use our power connection and it could just touch the other places that we don't want to. So yeah, that's not great. So just apply a little bit of solder on the tip of your soldering iron, heat up the pad and the wire, and then if feed some more solder in there. Looks like that should be enough. And this knot that we did over the mounting hole will just take some of the physical stress. We can test our solder with our multimeter. I want to see some sort of resistance between the ground and this pin. We have 45 kilo ohms, that 50 kilo ohms. Yeah, that looks pretty good. That's what I would expect. Let's do a few other connections. Now let's bring our heat shrink pieces over. Maybe you should just wait. You can just wait a little bit for the solder to cool down. It's cool enough. I'm just gonna bring the heat shrink over for this one and for the ground as well. Now we just need to shrink those things. So there are more appropriate tools for this, but I'm just going to use a lighter, like savages, to shrink these ones. You don't want to melt or damage your wires. Just a little bit of heat should be fine. If it's not great on the edges, you can just give it a few more passes and just give it some time because it will take a while. It won't go like, it will shrink slowly. A little bit over here maybe. We got our batteries connected. We got our PCB connected. All good. So I don't want to connect our LED straight onto the PCB or anything like that. I'm just going to use some jumper wires, female to female jumper wires, because I don't know where to pop the LED yet. Put our LED like this here. Just check it's strong enough. Well, you can solder the LED as well onto a bunch of wires too. It's not a problem. Whatever you want. I just want to prototype and play with a few things, a few different positions for the LED. So that's why I'm using the jumper wires. And then get in there, connect the positive and ground of the LED, the anode and the cathode of the LED. Also there, done. All right, now we need to connect our motion sensor module. Again, I'm just gonna use some wires, a blue one for the, now we won't connect the VCC, this one here anymore, we'll be using that. So I'm just gonna connect the output, blue. Yeah, again with these jumper cables, just make sure that they're connected. They should be able to hold it. If they are not, you can just get in there and using this little window, squeeze the metal parts inside a little bit. Okay, so we have the ground, which is this pin, I know. It's exposed. We have the output, should go to GP3, which is where we want. And now we just need to power our module. For the power, I'm planning to solder something there. Maybe one of these cables that I cut. So just have a female connector at one end, at the other end, nothing. So we're just going to strip that and then solder it. And yeah, that should be it. Now let's connect our module's power to our breakout board as well. 3.3 volts over here. Let's pop in our batteries in there and see what's going to happen. I've already programmed this pig. There's a software on it already that we're gonna talk about in a sec. Get all these batteries in there. No motion, it goes off. Give it a bit of motion. Yeah, it comes back on and then it goes off again. So maybe this is a little bit too short. This first one is sensitivity. The second one, I'm just going to crank it up a little bit. Yeah, just a tiny bit because it changes things a lot. Yeah, it's going on for a while now. And now it's over. Let's give it a bit of motion. Yeah, that's pretty good. So before growing our pumpkin, there's a couple of things that I want to check as well. So this thing, when we power it like this with 3.3 volts, and standby mode, it's supposed to consume like 50 microamps. And we are also in the code putting our micro into sleep when there is no motion, so it shouldn't be consuming it again on the microamps level. And probably the worst power consumer here is our regulator LDO, because it doesn't have a shutdown mode. It's always on, and that in its standby mode only consumes 0.5 milliamps. So all in all, when our LED is off, everything should consume in standby mode like half a milliamp. So we just want to verify that before we go and look at the code as well. I'm just going to pop out one of the batteries here, bring our multimeter over here, put it in current measurement mode, connect to the positive terminal, and then let's see. And our LED is on and it's, changing its brightness. We have like 10 milliamps there, but when it's off, we have 0.5 milliamps. So these batteries will last forever in the setup, especially in standby mode. You can pop in a solar panel or 5-volt solar panel or something like that. Just trickle charge them with like real low current, and then they will like literally be there forever, like for years. Yeah, it's still yet to come. Also, if you don't like the duration of the LED, you can just change the pots, the second one, a little bit. So when there is motion, it will just be glowing longer. Let's talk about our code a little bit before jumping into growing and carving our pumpkin. So we have this configuration bits as usual, flags. It's our micro is at 8 megahertz, and our MCLR GP3 pin is set as input. No pull-ups, that's fine. Watchdog timer is on and code production is off. Aside from that, we have these minimum duty and maximum duty templates where you can set them between, like, it could even be negative, but any values smaller than 0 or larger than 255 will mean some additional time in complete off and on states of the LED. A bit of interesting stuff happening on the option bit. This is like just your processor options. We set we need to clear T0CS, that's the timer 0 clock select, to set GP2 as digital output, because it has a preference to do that. And we have our timer prescaler, and we are also enabled GP wake up. So we will put our processor to sleep when there is no motion, and when there is any motion, the micro will wake up from sleep and it will continue operating. And the rest of the code is pretty much our pulsating glow from our pulsating glow video, which I will link in the description below, with one little addition that we are checking GP3. And if GP3 is 0, that means our motion sensor is not sensing any motion. And if our duty is at its minimum value, we just, put our processor to sleep. Here, because we are low side switching our LED, setting GP2, putting it to high, will actually turn off the LED, and that's what we want to do here, turn off the LED and go to sleep. And in this mode, the whole application consumes like 0.5 milliamps. And once there's a change on GP3, our processor will wake up, it will go through everything, and then it will just start animating our brightness here. You can change the code a little bit, play with min duty, max duty. You can just perhaps get some analog readings in there and edit to the duty, or manipulate the animation counter just to speed it up with a candlelight effect. But yeah, I'll just link the codes in the description below. And yeah, this is very simple. You can just port it to any other micros or Arduinos and everything else as well. Let's prep our pumpkin and pop everything in there. Alright, now our pumpkin is ready with its lid and cards. This model is from Thingiverse and I will link in the video description below. I printed in 2 parts as you have seen, and I used the material, as a material I used PETG, but you can definitely use any material you want, perhaps one of the semi-transparent ones, so you get like a better light diffusion within the model. I didn't bother any finishing, but you can sand it, paint it, like there's like all sorts of possibilities and different fun options which we're not going to get in this video. Just I could have cleaned it better even, but it gives a little bit of a more spookiness to it, so I like it this way, especially in this teeth area. All right, so we're just going to pop everything in there. It looks like we have plenty of space, but I'm just going to use some blue tack to just hold certain components in place, especially the motion sensor, because I want it to be as closest to the face area as possible, and then so we have like a nice because I don't think the sensor will work behind the PETG. This is quite thick, so it needs these gaps on the print to work properly. So I'm just going to pop everything in there and see how it works. We can start with just popping in the batteries. Let's wait for it to stop. Right, it stopped. Bit of a motion. Yeah, perfect. Now the LED, I'm just going to put the LED, let's push the cables in there. And the LED, I'll just put it on onto the lid. I want the light to diffuse from the bottom up, so I just bent it a little bit. Can use our blue tack to get it in there. Well, you can definitely play with the motion sensor, there it is, or you can just modify the model. Let's give it one final test. Well, hello there. Yeah, pretty good. All right, that's pretty much it. Hope you enjoyed my video and thanks for watching. Happy Halloween. See you next time. Bye.